Hey guys, it's Reed here, and this is episode 13 of Contest Coding. Today's problem is a simple, well not, yeah, basically simple, is a simple recursive maze problem, except you're counting the number of contiguous squares. And this one you see like there's M's that are touching, basically saying which is the largest patch of M's in the maze. There are probably a lot of different ways you can do this. One of the easiest ones is just to check every square, and it really isn't that efficient if you write it properly. And that's basically the one that I will show you how to do. First, you need to keep track of an instance variable of your max, and I'll just give it -1, so I know if there's an error in the code, it will return -1. Then you also need to make your map, which we'll just call map, and you don't need to instantiate that yet. First thing in your loop of how many runs you're going to be running is making the map and instantiating the object. And we know it's going to be 10 by 10 because we read the directions, and we make sure we reset max to -1 every time. Then what we're going to do is for r times, we are going to put map r as equal to the sin.next line dot to char array. Finally, we're going to just go and run our recursive loop, which we're going to do in a separate method called check, just to keep our code nice and clean. And that will make it work once we fill in the method void check, which is going to do for r equals 0 or is less than 10. Basically, it's for every single possibility. It's going to run 100 times. It is going to check and see if, I'll make this efficient, recur rc, if check is greater than max, max equals check, and then that'll be done. Now our last one, int recur, int r, int c. What does this have to do? Is it in bounds? So r greater than or equal to 0, r less than map.length, and c is greater than or equal to 0, and c is less than map r.length. And we're going to do an extra statement in here. Does map rc equal a moose? If it doesn't, we don't want to have to waste time checking stuff. So if it does, what are we going to do? We're going to set map rc equal to a little null character. We'll just use a dash to represent that for us. And then we're going to return 1, because we know there's at least one of these places in here because we already have a single map rc up here that equals an m, so we know there's at least one, plus everything else around it. rc plus 1 plus key recur rc minus 1. Why do I keep doing and signs for plus keys? Recur r minus 1c r plus 1c. Ooh, ran out of space. There we go. And if it doesn't find something, simple return 0. Now that should be all we have to do. I'll save that real quick. Java C. Compiles and see if it works. And it works first try. Run through the code and it did it. Okay, so now some more details about what I did. So it's pretty simple to understand that you just load the map like this. You know, it's 10 by 10, but you can just do to char array. It makes it really simple. Then I put it in another method where I just do check every place and do it. And you noticed what I'm going to do is I'm going to run, how many times does it actually get? I don't know. Well, it's going to run 100 times through this loop. I was trying to see if I could show you how quickly it runs, even though it's simple and it looks like it's going to run like 100 times. It does run 100 times, but it won't check every one because they're not going to be all map RCs. It's going to call the method. It's going to kick out right here because it's going to say, wait, map RC is in an M, so we don't have to check it. And it's just going to kick out. So it'll do almost all of them. It will just kick out immediately. I'm going to see if I can see. I'll see if I can do this. This might not work. It might work. Who knows? If map RC equals M, then print check Let's see how many times it does actually run. Okay, that 1, 2, 3, 4, 5. It's only going to run once for each location that is in that's a contiguous thing. Because it's going to erase all of them that aren't. So it looks like it's running 100 times. It's really only going to call the recursive method 5 times, which makes it really, really efficient and not worth wasting your time thinking, oh, it's 2 for loops 100 times. It's going to take so long. It's going to go out of bounds. For loops can be efficient if you write them properly. So thanks for watching, and the answers and stuff will be uploaded. See you, I don't know, probably Monday.